Thanks everyone for staying home to come to my talk. I'm Julia from the University of Warwick, and I'll talk about decision models from a multiple perspective point of view. We would like to develop a data to decision pipeline, which means that based on field studies, we can inform crop management decision models. So we are looking at work on two ends. On the data side, where we need to worry about variable organization to match with our model parameters, and data quantity and quality requirements, methodology for fitting, and nice visualization tools. And that all on top of optimizing decision models to fulfill the needs we have to achieve optimal trade-offs between different perspectives, economic, environmental, and societal needs, by more flexible decision rules that are commonly used so far. And we hope that through such evidence-based decisions, we can provide support for policy making in the longer run. On the data and methodology side, we do have some goals as well, which includes a better representation of the data in form of temporal data directories, benchmarking, and the establishment of algorithms. Now, looking into ecological perspectives is not entirely new. Actually, even as early as in '69, John Bennett tossed the name ecometrics to combine these two. We want to also throw in one other perspective, and that is Homo sapiens as a figure in the leisure mode. So we would like to, in a more general way, call that societal perspective. One of our case studies is an orchard and wild pollinators in New York State. It's a 2015 study, which consists of 16 orchards and has a number of samplings before and after bloom, including bloom index, pollinators, and pesticides. We noticed in a round of exploratory data analysis there's quite a dependency, a lot of variation, but there is a dependency of wild bee abundance from temperature, so there's definitively a case to make to include covariates. We have clearly a situation of multiple stage management because there are so many different steps that are being used in orchards. Modeling challenges were not negligible because of the individual management and a lot of missing data, among other challenges. Our second case study is probably known to most people here. It's the farm scale experiment from the UK. It has, most noticeable, it has a lot of different measurements, and it has 65 fields per crops on average. You can also get Met Office data to throw that into the mix. So the challenge was that, again, each farm does their own thing, so it's quite difficult to get an overview of the situation, and we developed a visualization that includes all the measurements at their somewhat irregular time points, and as a backdrop, we use hours of sunshine or other variables of interest. Now, the year can be confounding. Here we demonstrate that by plotting the crop height against the time axis, and we notice that that behaves different in the 3 years in the study. On the modeling side, starting point are Markov decision models. They're a beautiful way of describing decision processes in a probabilistic language and lead directly to the standard way of making decisions in economics using expected utility theory. We have generalized that, so it fits our needs better by making the branching structure more flexible and by introducing concepts such as influence on joint decision situations by so-called players as different as the environment, the crop, and the land manager. Now, they all can have different utilities, and there can also be memory, which is a deviation from the Markov assumption, so it makes it more flexible. And we can incorporate different time scales. Now, to communicate this, what we're doing better to others, we put everything in Shiny apps. The first one is about our visualization. So you can choose a number of variables and then generate different types of the plots of the temporal data directories. Another Shiny app is our decision tree building, which we used machine learning tools for clustering and things like that, even though the data set is a bit small. But as just to prove how this could be done for bigger data sets, we implemented it. We also implemented what we think of as a decision support tool, where a farmer could manipulate decision rules by giving preferences, and then based on the empirical evidence, a decision recommendation is being created. Now, this is just a quick summary of what we did on the different ends: decision models, data, and implementation. We are hoping that in the near future, data sets will become bigger by the inclusion of remote sensing technology, and we also hope that the sampling designs will be more uniform. Thank you very much to all of you for coming, and thanks to my collaborators, and now I'm looking forward to listen to other people's presentations.